I'm Patty Simpson with Simpson Math. Let's find the probability of this problem. So my brother and I were trapped on an island, and we each have a six-sided die that we carry around in our pocket at all times. So we had two six-sided die, and we found a banana on the island. So we had these two six-sided die and a banana. And we were trying to decide who was going to get to eat the banana. And we decided that what we would do is we'd play a little game where we rolled the two six-sided die. And my brother, being the nice guy that he is, said that if we rolled the two six-sided die and a 1, 2, 3, or 4 was the larger of the two six-sided dies, then I would get the banana. But if a 5 or a 6 was the larger, then he would get the banana. So for instance, if I roll these, in this case, I rolled 2 4s. So I would get the banana because 4 is the largest number. Let me roll it again. And here there's a 2 and a 1. So 2 is the larger number, so I would get the banana. In order for him to get it, there I rolled a 1 and a 6. 6 is the larger of the two numbers, then he would get the banana. So that we decided to play this game, and I want to know what's the probability that I get the banana? How much advantage do I have over my brother in this game? So let's find that out. Now we know that the probability, in order to determine that probability, we need to know the number of ways that I would win. In other words, the number of ways that I could get a 1, 2, 3, or 4 as the higher number. And then we need the total number of outcomes. So it's easiest maybe if we find the symmetric sample space to help us. So we're going to find all the different ways that we could roll these dice. Well, as we're rolling the dice, on one die we could roll a 1, a 2, a 3, a 4, a 5, or a 6. On the other die, we could roll the same thing. A 1, a 2, a 3, a 4, a 5, or a 6. I'm going to make a table that shows the symmetric sample space, that shows all the possible things we could roll. So for instance, I could roll a 1 and my brother could roll a 1. I could roll a 1 and my brother could roll a 2. I could roll a 1 and my brother could roll a 3. I could roll a 1 and my brother could roll a 4. I could roll a 1 and my brother could roll a 5. I could roll a 1 and my brother could roll a 6. So those are 6 possible outcomes from this game. Or maybe I roll a 2. Well, if I roll a 2, then my brother could roll a 1, a 2, a 3, a 4, a 5, or a 6. I could roll 3. If I roll a 3, my brother has those same possibilities that he could roll of 1 through 6. If I roll a 4, then again my brother has those possibilities of 1 through 6. I could roll a 5, and again my brother has those possibilities of 1 through 6. And then maybe I roll a 6 and he rolls a 1, or I roll a 6 and he rolls a 2. I roll a 6 and he rolls a 3. So this is all the different possibilities of what we could roll. This chart, this table, shows my symmetric sample space, all the different possibilities of what we could roll. Now I want to know the probability that I win. And in order for that to happen, the biggest number has to be a 1, a 2, a 3, or a 4. So I'm going to go through and circle. Well, first of all, the probability that I win, we know that the total number is going to be on the bottom. And there are 6 times 6. There's a total of 36 potential outcomes. 36 different outcomes. And I want to see how many outcomes do I win. Well, there's here I win because 1 is bigger. Here I win because 2 is the biggest. 3 is the biggest. 4 is the biggest. 5 is the biggest there though, so my brother wins. 6 is the biggest there, so he wins. Here, 2 is bigger, I win. 2 is bigger, I win. 3 is bigger, I win. 4 is the biggest, I win. 5 though and 6, my brother wins. 3 is the biggest. 3 is the biggest. 3 is the biggest. 4 is the biggest. 5 is the biggest, my brother wins. 6 is the biggest, my brother wins. 4 is the biggest. 4 is the biggest. 4 is the biggest. 4 is the biggest. 5 and 6 again, my brother wins. 5 is the biggest. 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 And 6 is the biggest. Oh, my brother wins all of those. 6 is the biggest. 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 And 6 is the biggest. Oh, my brother wins all of those as well. So I win, well, 1, 2, 3, 4 times 1, 2, 3, 4. I win 16 out of the 36 times. Or we could reduce that. 4 goes in there 4 times, and 4 goes in there 9 times. So 4 out of 9 times, I'm going to win. Hey, wait a minute. If I'm going to win 4 out of 9 times, what's the complement of that? Or how many times then would my brother win? What's the probability then that my brother wins? My brother wins. Well, if I'm 16 out of 30, the rest of the time he would win. So we could find that complement by saying 1 minus the 16 out of 36, or the 4/9. Well, 1 is 9/9 minus 4/9. So that means the probability he wins is 5/9. He has a better chance of winning. I thought that he was being nice by letting me have 1, 2, 3, or 4, and it turns out that he has a better probability of winning the banana. Luckily, right about then, my other brother showed up in a boat, and we got to leave the island, so it didn't matter anyway. Math Made Simple is Simpson Math. Thanks for watching.